1.9 is inverse functions. What does the word inverse mean? Opposite, okay? Inverse means opposite. We are going to talk about inverse functions today, and we're going to find them algebraically. We'll talk about graphically a little bit. We'll talk about graphically later on. But I need you guys to understand what inverse looks like, what the notation is, that sort of thing. Okay, guys, so look what I have highlighted. Do you see those two functions? F of x equals x plus 4, and f negative 1 of x equals x minus 4. Everybody see those two? Okay, we're going to compare. If you notice, the notation on our original function is f of x. The notation on the inverse is that little f negative 1 of x. That's you telling me that that is the inverse of a function. Okay, then if you look at the function itself, do you see x plus 4 and x minus 4? How are those different? Instead of adding, you're subtracting. You're doing the inverse operation, correct? Notice the points. Your domain in the original is 1, 2, 3, 4. Your range is 5, 6, 7, 8. What happens to the domain and range of the inverse function? They switch. Okay, now, we're going to talk graphically about this a little bit, but we're going to get to it later on in our different chapters. We're going to talk mostly algebraic today. But inverse functions are just opposite of each other. All right, algebraically, we're going to work it out like I just said. I don't know why this is still there. And then graphically, we'll talk about in a little bit. It's very, very important that you guys understand that inverse notation is that little f negative 1 of x. All right, you are not going to be given any on your test that you have to prove that a function is an inverse of each other. I want you guys to see how this is done so you understand the process. You're going to have to find the inverse algebraically. But if you're going to prove, you're going to show that functions are inverses of each other, you're going to do compositions. So you're going to say f of g of x, and then conversely, you're going to do g of f of x. You're going to take one function, put it into the other, and then you're going to do vice versa. So we're going to practice what we did yesterday, okay? In this first example, I'm going to take the g function and do what with it? Put it into the f function. So my g function, I'm going to put it right in there to the f function. So everybody watch. We're going to have 2 instead of x. What do I substitute in for x? The cube root of x plus 1 divided by 2. Then I finish the rest of my function. So it's cubed minus 1. And now we're going to simplify. How can I start simplifying here? 2's can't cancel yet. The 3's, right? The cube root and cubing cancel each other out. So then I'm left with 2 times x plus 1 over 2 minus 1. Now what? The 2's will cancel. So now I have x plus 1 minus 1. Then what? The 1's cancel, so I'm left with x, okay? Just practicing what we did yesterday. Taking one function, plugging it in the other. Now we're going to do the exact same thing on the other side. We're going to do the opposite way. We're going to take the f function and plug it into the g. So take this whole f function and put it right there. So I have the cube root of, instead of x, I'm going to write 2x cubed minus 1, and then I have plus 1, right, divided by 2. So how can I simplify here? The 1's will cancel out, so I'm left with the cube root of 2x cubed over 2. The 2's cancel. Good. Then I'm left with the cube root of x cubed. So what am I left with? X. When you are proving that functions are inverses of each other, when you plug g into f and then f into g, you should come out with just x. They are inverses of each other. If you plugged one in, if you plugged f into g and got x, and then you plugged g into f and got 12, Are those two things inverses of each other? No. Again, I'm not going to have you on the test verify inverses. We'll do that later on. We're just algebraically going to find the inverses. We're going to figure out how to find them algebraically. That's what we're focusing on now. Somebody asked last period, it was a very good question. And she said, well, the domain, remember on that first slide we talked about how the domain and the range switched? But she said it's not that they went opposite, like one, positive one and negative one, or vice versa. Very good observation. When you have inverses, the inverses are not reflected over the x or y axis. It's reflected over this line, which is y equals x. So that's why the x and the y's change positions. They don't change signs, they change positions. And again, we'll talk graphically later on. We're not doing that right now. Today we're going to talk about finding inverses given an algebraic equation. So this is what I want you to do. Write down the steps. Step number 1, you got to follow these steps. You're going to replace f of x with the letter y. All right, then you're going to, number 2, you're going to switch the places. So you're going to switch x and y. So first thing you do is replace f of x with y. Second thing you do is physically switch the x and the y, their spaces. Then you're going to solve for y. We'll say the new y. And then at the end, you're going to replace y with f negative 1 of x, because that's you telling me here is the inverse. So your 4 steps, you follow these steps, you guys will be just fine. You're going to replace f of x with y. Then you're going to switch the places of x and y, solve for y, then at the end replace y with f negative 1 of x. And I promise you it's as easy as that sounds. So let's do number 1 together. All right, step number 1. Step number 1 is to, okay, replace f of x with a y. So y equals 5 minus 3x divided by 2. Agreed? Okay. Step 2. What's step 2? Physically switch x and y. So this becomes x equals 5 minus 3y divided by 2. Next step. Solve for what? Solve for the y. This is my new y. That's what I'm talking about. So you're just going to solve for y. So how would I do that? Algebraically, how do I solve for y? Multiply both sides by 2. Agreed. So my 2's cancel out. I have 2x equals 5 minus 3y. Then what? What am I going to do? Subtract 5. Okay. So we're going to subtract 5 from both sides. Good. So I have 2x minus 5 equals negative 3y. Now what? Divide both sides by negative 3. So I have y equals 2x minus 5 divided by negative 3. And then what's my last step? What I told you guys to do. Change the y to f negative 1 of x. You forget that step, guys, I'm taking off at least 2 points because that is denoting that this is the inverse. If you wanted to write this as negative 2x over 3 plus 5/3, that's the same thing. Or you can just leave it. But right here, you just algebraically solve for the inverse. And some people are like, well, how do you know if you're right? How can you check it? Your original, here's my original up here, right? And you guys see our answer. In our original, do you guys agree that we were adding 5, multiplying by negative 3, and dividing by 2? Okay, so in my answer, or in my inverse, instead of adding 5, what are we doing? Subtracting 5. Instead of dividing by 2, what are we doing? Multiplying by 2. Instead of multiplying here by negative 3, what are we doing? We're dividing by negative 3. So you should be able to go from your original to your inverse and kind of pinpoint, okay, there's the opposite, there's the opposite, there's the opposite. Now, if you forget, if that first step you forget to switch the x and the y, that's a problem. All right, that is a problem. If you have something like number 2, let's look at number 2. I'm going to rewrite number 2. Maybe you see number 2 written like this. You guys agree that those two things mean the same thing? Yeah. Yeah? Okay. So let's solve this. What is my first step? How do I algebraically find the inverse? First step is to what? Let's replace f of x with y. Now we do what? Switch places, yes? So x equals 1/5 3y plus 4. Now I'm doing what? Solve for? Nope. Solve for y. We're solving for y. So what's the first thing? How do I isolate y? What's the first thing I'm going to do? Multiply both sides by 5. Good. So I have 5x equals 3y plus 4. Now what? Perfect. Subtract 4. 5x minus 4 equals 3y. Now what? Divide by 3. So y equals 5x minus 4 divided by 3. Or, what's another way I could write it? 1/3 times 5x minus 4. Again, either way you want to write it, that's fine. But if you look at your original to your inverse, you should be able to see the difference. You got to have your inverse notation. So 5x minus 4 divided by 3. So let's check. Let's look. In my first, my original problem, I was multiplying by 3. In my inverse, I'm doing what? Dividing by 3. In my original problem, I was dividing by 5. In my inverse, I'm what? Multiplying by 5. In the original, I had plus 4. In my inverse, I have minus 4. This last one, I want to add a little bit to it. Hang on. Let's add a plus 7 back here. All right, so I understand that a lot of you can just go like this. X equals, right, 2y minus 3, and then have your plus 7. Some of you in here are like, I don't want to cross off the g of x, then write a y. Okay, I get that. I'm just make sure you remember to switch the place of the variables. You don't get yourself confused. I think it's really good for those of us who need a little extra repetition to just do the same thing every time. But if I'm going to solve for y here, guys, what would the first step be? Subtract 7. So I'm going to subtract 7 from both sides. So I have x minus 7 equals the square root of 2y minus 3. All right, now what? I'm going to square both sides. Guys, when I square both sides, can I just put a 2 right here? What do I have to put around x minus 7? A parenthesis, because you're squaring the whole side. Make sure you do that. Because x minus 7 squared is very different than x minus 7 quantity. Okay, here we go. I'm going to talk a little faster. So what happens when you square a square root? It cancels, right? So I have x minus 7 quantity squared equals 2y minus 3. Now what? No, don't FOIL. We're trying to get y by itself. I'm going to add 3. So I have x minus 7 quantity squared. Then we have our plus 3. That doesn't go inside of the parenthesis or anything like that. And now what? We're going to divide by 2. So I have y equals x minus 7 quantity squared plus 3 divided by 2. Another way I could write that would be what? 1/2 x minus 7 quantity squared plus 3. What do I have to put instead of y? G negative 1 of x. Would I mark off points if this started g of x and you put f negative 1? No. Not focused on the letter. I'm focused on the fact that you have the inverse notation. Now, this is completely simplified. I do not want you guys multiplying or foiling x minus 7. You might get something on your test that's to the 6th power. I don't want you to write x minus 7 out 6 times and foil it and get these ridiculous numbers. Leave it. That's fine, exactly how it is. And then if you check, look at your original. In the original, we had a square root, and here we're squaring, yes? In the original, we were adding 7, and in here, we're subtracting 7. In the original, we were subtracting 3. In the inverse, we're adding 3. And in the original, we were multiplying by 2. And in the inverse, we're doing what? Dividing by 2. Does that make sense? You guys okay? All right, that's it. That's all we have for inverses.